So we've got, first off, number one. The big thing on number one was the thing I told you. Write this down on the day of. I said, things people forget. Roman numerals. Now, I think that made people over-apply the Roman numerals on question number one, because this is what I saw a lot of. Okay, silver nitrate, which was fine. That's what this is. Plus copper 1. When copper is an element, does it have a charge? Then it should not say that it does. You only put in the Roman numerals in the compounds. Okay, and I did see that happen on quite a few. I put 2 out of 3, unfortunately, on number 1 on a lot of the 80 whatever that I marked last night. Okay, we don't want to over-apply that rule. Remember that the Roman numeral is only there to tell us in a compound which charge was used to make that compound. When this thing is an element, it has no charge and thus doesn't need an indicator as to what its charge is. All right, is everybody following me there? Right, and so that was the mistake that happened on that one. It was already balanced. It was all ones. Okay. All right, number 2. So we have sodium chloride reacts with hydrogen sulfate to give sodium sulfate and hydrogen chloride. Most common mistake I saw in this question was people putting di in front of all the hydrogens. All right, if hydrogen is listed first, it's acting as a metal, which means this is an ionic compound and doesn't need prefixes. And this is an ionic compound and doesn't need prefixes. All right. In terms of the balancing, you can start with hydrogen. There's 2 over here, so there needs to be a 2 there, and that means you need a 2 here to give you the right number of chlorines and sodiums. Okay, everybody with me there? Okay. Number 5. So number 5 was a combustion reaction, and it had an even number of carbons. So what we needed here for naming was dicarbon hexahydride plus oxygen. And again, I did see dioxygen or dioxide a few times, but remember, this is an element. Okay, it's a special element. That's its name, oxygen. Okay, plus water, or goes to water, sorry, plus carbon dioxide. All right, so that's what our naming should have looked like on that one. And then we have C2H6, so we start with a 2, go over to the carbons, we need a 2 there. Then we look at the hydrogens, there's 12, so a 6 there. And then 2 times 2 is 4, plus 6 more is 10. Okay, what did I mess up here? Right. And it's supposed to be 4. That's why my numbers aren't 2, 7, 6, what they're supposed to be. Okay, sorry guys. 4 in front of that. 4 times 2 is 8, okay, plus the 6 more here, which gives me 14. And then I have 7 there. Oh, that's good. Okay. Questions on 5? Okay, number 9. Okay, I guess number 9 is not on there. Okay, number 9. For this one here, we have zinc hydroxide. Right, zinc does not require a Roman numeral. It only has one possible charge, and that is 2 plus. All right, but I did see a Roman numeral on that several times. Plus hydrogen phosphate. Again, an ionic compound, so no prefixes are needed there. Gives us zinc phosphate plus water. Okay, now for the balancing part here, I mean, there's a few things that start with a 3, so we might as well look at zinc first and put a 3 here. That gives me how many hydroxides? 6. So I need a 6 here. All right, and then that gives me 6 hydrogens, so a 2 here and a 1 there. Questions on that one? Okay. Number 15. Sorry, 13. All right, so iodine crystals, and honestly, guys, a lot of people had trouble with 12 and 13 because they forgot that iodine and chlorine are molecular elements and thus come as pairs when they are by themselves. Most common mistake on this one. Okay, so for number 13, that was the thing. Iodine crystals are I2 plus chlorine gas, Cl2, gives iodine trichloride balance the chlorines first. There are 3 here and 2 here. What's the lowest common multiple? 6, right? So I need a 2 here and a 3 here, and that means the iodines work out now, and we're good. All right, but that was the most common mistake, was that people forgot either iodine or chlorine or both were molecular elements. Okay, be sure you remember that. That's why I'm letting you use your periodic table on the exam on Monday, so that you have the molecular elements identified on there. Colton, question? Oh, okay. Okay, 15. Potassium nitrate. This was people struggled with this one. And honestly, the reason they struggled was in the writing of it, not so much the balancing of it. So it was the naming that seemed to give people trouble here. So we have potassium nitrate, which is this, KNO3. Breaks down into potassium nitrite, KNO2, and oxygen gas. All right. Now, here's our problem. Odd number of oxygens, even number of oxygens. How do we solve that problem? Multiply it by 2. All right, let's start balancing. 2 potassiums, 2 potassiums, 2 nitrogens, 2 nitrogens, 6 oxygens, 6 oxygens. Okay. And sorry, and that one was a decomposition reaction, because you were supposed to identify the reaction types on those 3 as well. And 16, barium chloride. So barium is Ba and chlorine is Cl. This is a +2 and this is a -1, so BaCl2 is mixed with potassium carbonate, K with CO3. This is a -2 and a +1, so we need K2CO3. We'll form barium carbonate, BaCO3. Those are both 2's, so they can balance off that way. And potassium chloride, KCl. So right now, the only thing that's out of balance are chlorine and potassium. So a 2 here will fix that problem, and it is a double replacement reaction. Okay. Biggest problem I saw on that one was swapping and dropping the barium carbonate. Had a lot of people writing it was 2 and 2, or it was 2 and 1, and it was just some odd things happened with the swapping and dropping with that one. Remember, when you have a polyatomic ion, you treat it no differently than you would anything else. It's a -2, this is a +2. They'd both be 2's, but we don't write that. They reduce down to 1. Okay. Number 19. Yeah, and this one gave people some trouble too. So aluminum reacts with, so we got aluminum metal, reacts with copper 2 sulfate, that is CuSO4. This is a -2. The Roman numeral tells us copper was a 2, so that compound is properly swapped and dropped as it is written. It's a single replacement reaction in which we're going to get aluminum sulfate, AlSO4, okay, and copper. Now, here's where the problem arose on this one. Dropping and swapping aluminum sulfate. So it seems like we struggled a bit with dropping and swapping things that had ionic compounds in, or had polyatomic ions in them. Sulfate is -2, aluminum is +3. So the 2 drops down to here, and the 3 goes to here, which means I require brackets. Okay, so we have Al2SO4, 3. Now I can start to balance. The sulfate is out, so we need a 3 here, which gives me 3 copper. I need a 3 there. I have 2 aluminum, so I need a 2 here. Okay, and that was like we said, a single replacement reaction. Cool. Doesn't the what in the brackets? No, it only affects the sulfate. Small numbers affect only what's immediately behind them. The big numbers, the coefficients, affect the whole compound. Okay? All right, number 22. So yeah, people struggled with this one, I think, just because they didn't like having water on both sides. All right, and in this reaction, there's actually 2 possibilities, but realistically, this is the one we should have seen. CaOH2 plus H2O. Double replacement. Okay, we got 2 ionic compounds. The OH goes with calcium, the oxygen goes with hydrogen, and now we have to rebalance by putting a 2 there, and we're done. Okay, realistically, the other thing that people wrote, but I couldn't accept because it meant no reaction happened, was exactly the same things on the product side. All right, because that means you were looking at this like it was H2O and you were swapping, and then it means that nothing happened. Well, I wouldn't predict this reaction as though nothing happens. Okay, because that's not what the point of it is. Okay, and 25. So H2SO4 and aluminum hydroxide, double replacement reaction, so we swap the metals, meaning we have HOH as one of the compounds and aluminum with sulfate. Then we've already had this one. It was on a question we did just a minute ago. That's going to mean Al2SO4 3. I had some weird swaps and drops on this one. Oddly enough, I don't know if it was in this class or the other classes, but I saw H3OH2. I saw a whole bunch of weird things. All right. When you balance a reaction, you use the big numbers. All right. So if we go back over here, we have to put a 3 there to balance the sulfates, which gives me 6 hydrogens. So I put a 6 here. That gives me 6 hydroxides, a 2 here, and that makes the aluminums work. Okay. So 3, 2, 6, 1 for that one. All right. That's all you guys had on the list. Any others that have come up since? Don't be afraid to ask. MJ, 27? Yep. Okay, so we had strontium bromide with ammonium carbonate. Double replacement reaction. Remember, ammonium is kind of special in terms of polyatomic ions because it's the only one that is positive. It's the only one that acts as a metal. All right. So I'm swapping it with strontium, meaning strontium will end up with carbonate, +2 and -2. Okay, and ammonium will end up with bromine, NH4, Br, -1, +1. So this one is fine as well. Now we have to balance. There's 2 ammonium on this side and 2 bromine on this side. Fortunately, they're together over here. So only a 2 is required to balance it. Okay. Everybody with me there? Okay. Any others? Okay. Oh, cool. 26? Yep. Okay, so potassium hydroxide with hydrogen phosphates. Again, here's the 2 metals, hydrogen and potassium. So when we swap, we end up with water. Okay, plus a salt, which is KPO4. Remember, the PO4 is -3, so we drop that down to here. We have K3PO4, which means we need to put a 3 here, and then a 3 there, and that will make everything work. Okay, 30? Okay, so barium chloride, hydrogen phosphate, again, double replacement reaction where we swap the metals. So barium ends up with phosphate. And again, this one was the drop and swap problem, okay, that I saw in a lot of them. -3 +2, so we get a 3 here, brackets, okay, 2 here. Ba3PO42 plus HCl. And then when we balance, we got to put a 3 here, which gives me 6 chlorines. So a 6 there and a 2 here. 28? Yeah, this one, odd, because for the first time in any of your combustion reactions, the number on the hydrogen wasn't 2 plus, or 2n plus 2 in terms of its number, right? It was actually the same number as carbon, but in actual fact, it changes nothing about the way you balance it. All right, we still balance alphabetically. We still use the rule of 2. Right, so that's what we start with here. Start with a 2. Our products are CO2 and water, as they always are. 2 times 6 is 12, so I need a 12 there. 2 times 6 is 12, so I need a 6 here. 12 times 2 is 24 plus 6 more is 30. And 15 times 2 is 30. All right, as long as you have carbon and hydrogen together, always obey those rules. 4? Oh yeah, this is a good balance. This is a tough balancing one. All right, biggest thing I saw though, not the balancing, oddly enough, on this one. Forgetting Roman numerals, even though I told you about them. Okay, but it happens. So we got iron, or sorry, not iron, lead, sorry. Lead, and it's got to be a 2. Nitrates. Okay, breaks down into, and a lot of people remember the Roman numeral here, and then didn't do it here. Okay, I know some of you are laughing at yourself, kind of kicking yourself, but it happens. Okay, lead 2 oxide plus, and I told you guys that day that's not nitrite, that it was nitrogen dioxide. okay, plus oxygen. All right, and then to balance, the best thing to start with is actually your nitrogens. But before you do that, you have to realize that you have an odd-even problem. Okay, there are 5 oxygens over here and 6 over here. So you do need to start with a 2. Right? Then you can go to the nitrogens and say, all right, well, I've got 4 nitrogens here, because this 2 means there's 2 times 2 more is 4. So 4 goes there. Balance my leads, 2 here. Now I can balance my oxygens. I have 12 oxygens on the reactant side. Over here, I have 2 plus 8 is 10, plus 1 is 12. Plus 2 is 12. But a 1, you get what I mean. Okay, does that make sense? It's a bit tricky on that one. You may possibly get a balancing question like that on your unit exam. Not a prediction question or anything like that, because obviously it doesn't fit perfectly with a decomposition reaction. But you could be asked to balance one like that. Okay, any others? All right then. Here's what we want to do now. All right, on your phone, go to my website, same as you always do. Okay. By the way, I know some people. Did I tell you guys? I put my email address on here now, right? Because people couldn't find it. All right. If you go to Physics 20 textbook and Google quizzes, that section here, okay, I've changed how I did this so that it'll load faster and work better. It says Coder's Google quiz response form. We're just going to use that same file for every Google quiz we do now. It doesn't have any questions in it. It just says 1, A, B, C, D, and E is don't know. All right. Honestly, guys, if you don't know, click don't know. All right, because that tells me something when I look at the data. Well, half of us just didn't know. We should probably go over that. All right, as opposed to just struggle through and guess. Just say don't know. It's better. All right, so click on that. When you do, you will get this. All right, and that's where you're going to enter your answers from. Okay, this quiz here on reactions. Oh. All right, so I will have to scroll down a little bit as we go. Right, but that's not an issue. Okay, so that's what we got right there. We'll start off with those. Okay, just fill in A, B, C, or D for those, and I'll scroll down in a few minutes and show you the rest. And then when you're done all of them, click Submit, and we'll have a look at how we do here. Where's the quiz? This is the quiz. Go to, oh, sorry. Okay, right here. Coder's Google Quiz Response Form. Okay, if you click on that, you should see this. Why can't the stuff here work? Okay, so far so good. All right, we got 18 out of 20. Getting number 1 correct, because number 1 was D for the correct answer. Okay, so we'll just quickly go back here to number 1. Okay, which word equation is correct here for magnesium reacts with chlorine? Well, the only one that has magnesium plus chlorine as the reactants is the bottom one, because for A, the arrow is in the wrong place, and that was the one that other people chose. I think you just didn't look closely enough for arrow versus plus sign. Okay, so all it was just basically naming and writing an equation correctly. Okay, for number 2, same thing. We had 19 and 1. Okay, so it was B here for number 2. 3 NaCl plus 1 FeNO33, okay, gives us 3 sodium nitrates and 1 iron chloride. Okay, for number 3. Okay, we got a bit of a smattering there on number 3, so we'll have a look at that one. Okay, on number 3, okay, what are the coefficients for the following reaction? Well, here's what we need to do. Listen up here, guys. Nitrogen monoxide is NO plus CO, okay, gives me nitrogen gas plus carbon dioxide. Well, you can see we've got the odd-even problem here with the oxygen. So the first thing, well, that's not a 3, okay, is a 2, because that doesn't help the odd-even problem. Okay, well, now I've got 2. Now my nitrogens work, okay, and now I've got, all right, how many oxygens over here? Okay, I've got 3, but if I put a 2 here, does that take care of that problem? Okay, so now I've got 4 oxygens over here, 2 carbons, and a 2 there. We'll fix it all. All right, so it should be 2, 2, 1, 2, which was B. All right. For number 4, quick look here. Okay, so we got a few don't knows on number 4. So let's have a look at number 4 then. Okay, so here's what we did. Number 4, honestly, guys, number 4 should be this fast. Okay, it should honestly be that fast. Here's what we do on number 4. Sodium sulfate is added to one of these 4 things. So all we do is go to our solubility chart where sulfate is and go down to the second row. If any of these, iron, potassium, magnesium, or barium are in there, they will not be soluble with sulfate. How do I know barium ends up with sulfate? What kind of reaction is this? It's a double replacement reaction. All right? I know that one of these things would end up with sulfate. All I have to do is find which one isn't soluble. And when you look at your solubility chart, barium is not soluble with sulfate. Everybody follow? Make note of that one. There's one just like that on the unit exam and the multiple choice. Wow. More people should have been listening to that because I only going to say it once. Okay. Number 5, which of the following is a balanced chemical equation? Well, we probably did okay on that one. We'll just have a quick look here. Yeah, we're 18 and 2. Hey, number 6 went well. Good. All right. As long as B is the right answer. Okay, good. Yeah. All right. And number 7, well, we got a smattering, so let's have a look at number 7 real quick here before the bell goes. Okay, number 7, aluminum chloride bubbles and bubbles of hydrogen gas are produced. So those are the products, not the reactants. All right, so we got hydrogen gas and aluminum chloride as our products here. Okay, this can't be right. C can't be right because aluminum has a charge of +3, so that's no good. Okay, this one here shows aluminum chloride properly balanced, and it's the only one that has it on the products side. All right. Process of elimination, right? Okay. Sometimes you don't have to necessarily think through the whole thing. You just have to read enough of the question to eliminate the 3 distractors. Alrighty. Okay, I'm sorry we didn't get to the mole one, okay, but you've got a lot of mole worksheets with the answers on them or the key to them, okay, over the weekend. Study hard over the weekend, guys. You want to be ready for Monday.